This is part 3 of our presentation on binomial probability. And actually, this part is not technically about probability. It's about how to find descriptive statistics from a binomial distribution. So the title of this presentation is Finding the Mean and Standard Deviation of a Binomial Distribution. And we're going to be using the calculator to do this. We see here, I'm going to read this right here, we see that we're actually going to be learning two things in this presentation. First, we're going to be learning how to find the mean and standard deviation of a binomial distribution. And then we're going to learn how to determine whether a particular event is unusual by using the mean and standard deviation. There are formulas for the mean and the standard deviation of a binomial distribution. Here you see the formula for the mean. The mean, let's talk about this symbol here. This symbol is a Greek letter called mu. It's spelled mu, pronounced mu, and it stands for the mean of a population. And generally when we're talking about a population, when we're talking about a distribution, that means we're talking about a population and not a sample, generally speaking. So the symbol for mean here is the symbol for population mean, and that's mu. And here we are talking about it right in the next bullet. And the formula for the mean is n, how many values are in whatever thing you're talking about, times p, the probability or the percentage. If you remember from the previous presentations on binomial, whenever you hear the word binomial, your next thought should be npx. Well, this is the same n and p that we were talking about with that rule. So to use this formula, you just need to find n and p in the problem and multiply them together. That result will be the mean, which we call mu. And we're going to see this in an example below. Just like there is a formula to find the mean, there is also a formula to find the standard deviation. And here you see the formula. Sigma, that is the Greek letter, and that stands for the standard deviation of a population, equals the square root of n times p times q. So here we see the symbol for a population standard deviation is sigma. When we hear binomial, we think npx, and it's the same n and the same p. We find n and p in the problem, and we calculate q. So you may not have heard of q before. What is q? It is the q is the complement of p. That means q plus p must equal 1, which means you can find q by taking 1 and subtracting p. Once you have n, p, and q, you multiply n times p times q, which, by the way, if you just did the n times p times q, you look at this up here without the square root sign, that is the formula for the variance of the binomial distribution. So once you have multiplied these three things together to find the standard deviation, which is sigma, you just find the square root of the result of that, which again is the variance. And we'll talk about this in the example below. Here is the example, and this is from the Triola textbook, section 5.4, exercise number 11a. And here's the problem. Mars Inc., Mars Incorporated, claims that 16% of its M&M plain candies are green. A sample of 100 M&Ms is randomly selected. Find the mean and standard deviation for the number of green M&Ms in such groups of 100. The formula for the mean is mu equals n times p. In this case, n equals 100, p equals 0.16. So 100 times 0.16 is 16. So that is the mean. The formula for the standard deviation is sigma equals the square root of npq. We already know that n equals 100 and p equals 0.16. Q equals 1 minus p, So 1 minus 0.16 equals 0.84. So that is Q, 0.84. First, we need to calculate N times P times Q. So that's 100 times 0.16 times 0.84. And that equals 13.44. This is the variance. Again, we're trying to find the standard deviation, but this is the variance. To get the standard deviation, we simply take the square root of the variance. So the square root of 13.44 is 3.67, which is the standard deviation. By the way, in case you don't know how to do this on the calculator, let's go ahead and do this process right here. First, we'll do N times P times Q. So that's 100 times 0.16 times 0.84. And there's the 13.44. That again, that's the variance. To find the square root of that, we hit the second key and see the little square root sign right there. We're going to hit that. And then we want the square root of this of our previous answer. So you see this little answer thing down here, we're going to use that. We're going to hit second answer. So where it says ANS there, that means it's just picking up the 13.44. We hit the enter key, and there is our standard deviation, 3.666, which I've rounded to 3.67. It's as simple as that. Well, now we're going to use this mean and standard deviation to determine if a particular event is unusual. And here is the rule. A particular event is unusual if it is more than 2 standard deviations away from the mean. This rule right here is called the range rule of thumb. And often you'll see it expressed using notation, and it looks like this. The maximum usual value is mu, or the mean, plus 2 standard deviations. And the minimum usual value is the mean minus 2 standard deviations. So all this is doing is using notation to express this same rule up here. This down here says the same thing as this up here. So what would be an unusual number of green M&Ms in a bag of 100? We're going to look at all this on a number line. So I'm going to ask you for the moment to not look at all these pretty colors and things here and just focus on this line right here. See that line? This is a number line, and in the middle we're putting the mean, or mu. And we're using this for the same problem that we did earlier in this presentation. Our mu, or mean, was 16. Each standard deviation was 3.67. So as we go to the right on the number line, we are adding 1 standard deviation at a time. So if you take 16 and you add 3.67, you get this number right here, 19.67. That's 1 standard deviation above the mean, and here you see 1 sigma. It's 1 standard deviation above the mean. Well, if we add another standard deviation, 3.67, that now gives us 23.34, and that's 2 standard deviations above the mean. If we add 1 more standard deviation, another 3.67, that takes us to 27.01, and that's 3 standard deviations above the mean. In the same way, we can go to the left, or below the mean. If we start with the 16, the mean, and subtract 3.67, we get 12.33. And once again, that's 1 standard deviation, but in this case, it's 1 standard deviation below the mean. We subtract 3.67 again, we get 8.66. That's 2 standard deviations below the mean. We subtract 3.67 again, that takes us to 4.99. That's 3 standard deviations below the mean. Remember, we're trying to find out if it is unusual, if we have an unusual result, or what number of green M&Ms would be unusual. And the rule is it would be unusual if it's more than 2 standard deviations away from the mean. Well, here you see this 2 sigma, and here you see this 2 sigma. Those points are 2 standard deviations away from the mean. This one is above the mean, this one is below the mean. So this green shaded area is the area within 2 standard deviations, and we call those usual values. And the red shaded areas are outside of 2 standard deviations or beyond 2 standard deviations from the mean. These are unusual values on the high end, and these over here are unusual values on the low end. So any score, I can't even remember what this problem was talking about, but any value above 23.34 would be unusually high, and any value below 8.66 would be unusually low. So if we look at this verbiage down here, it says 24 green M&Ms out of 100 would be unusually high. And we can see that because 24 would be over here somewhere. That would be in the red area. So that would be an unusual value. And 8 would be unusually low. 8 would be to the left of this 2 sigma line here. So that would be unusual. It would be unusually low. But 9 green M&Ms, that would be over here. That would be usual. That would be in the green area. And so would 23 green M&Ms. That would be here. In fact, every number between 9 and 23 would be usual. And that's what we're talking about, is how many green M&Ms would you expect in a bag of 100? Anywhere from 9 to 23 would be usual. And that's the end of this presentation.